Good afternoon, students. Again, welcome back to LNT College Multimedia Studio. Today, we have brought an interesting topic, that is revolution of coordination chemistry. Okay, so in the previous lectures, I have given you a detailed overview of the Werner's experiment for modern coordination chemistry. But in this lecture, we will try to explain by considering uh, other compounds uh, from the same uh, family. So that is actually COCl3 NH3. So by adding these two reagents, he has got actually series of compounds, that is COCl3 into 6NH3, COCl3 into 5NH3, COCl3 into 4NH3, COCl3 into 3NH3. So these are the four chemical adducts. So Werner actually found in his experiment through the reaction of this cobalt chloride with ammonia. Okay, right. So these four compounds actually have different colors. So this is yellowish color, right? This is purple and this is green and this is blue green. So because of the color variations, so they got uh, four compounds in a different colors. Okay, so in the first chemical adduct, he has established a formula like that. This is CONH3 का whole 6, and all chloride ion exist in the outside of the coordination sphere. So this is the chemical structure of this complex compound, and he has established that this compound actually possesses three primary valency, indicates that complex bears 3 positive charge, and coordination number 6 indicates that 6 ammonia molecule is surrounded to the cobalt 3 plus. So it has actually primary valency, that is 3, and secondary valency, that is 6. So this 3 indicates oxidation number of cobalt is +3. Okay, and 6 ammonia molecule is directly attached to this cobalt to form a particular geometry called octahedral. So octahedral geometry, right? So if the coordination number is 6, it means the geometry of the complex compound is octahedral, right? So this is the compound. So that was actually uh, elaborated as octahedral. So this compound bears yellow color. Okay, and next compound is cobalt chloride COCl3 into 5NH3. It means there is 5 ammonia molecule and 1 chloride ion in the coordination sphere. It means that is CONH3 whole 5, and 1 chloride ion is inside and another 2 chloride ion outside, right? So this is the structure of the adducts, that is COCl3 dot 5NH3, right? So 5 ammonia molecule and one chloride ion, they are directly bonded to the cobalt center, and two chloride ion exist as counter ions in the outside of the coordination sphere. Okay, so again here coordination number is 6, 5 from ammonia and 1 from chloride. So total coordination number is 6. In this complex compound, cobalt still maintains its oxidation state, that is +3. So primary valency is constant. Here primary valency, it means oxidation state of cobalt is +3. So here this coordination sphere is heteroleptic, right? So this is heteroleptic. This is heteroleptic coordination sphere. So because of the different ligands which are present in the coordination sphere. So here Werner's actually added silver nitrate solution in this compound. What he has got? He has got CO and H3 whole 5 Cl, and that is here 2Cl minus, it means 2 plus, right? So one complex ion, that is cation, and two chloride ion. So total number of ions is 3, right? For this compound, through the measurement of actually number of ions was performed by the Werner, and he has found there is 3 ions which are present in the aqueous system. So it indicates 1:2, 1:2 salt, a type of salt, right? So here 3 indicates that total number of ions is 3. Okay, so again the geometry is octahedral because coordination number is 6, octahedral, right? So in the another adduct, that is CO and COCl3 into 4NH3. So in this chemical adduct, 4 ammonia molecule actually, and since we have to maintain the coordination number 6, so 2 chloride ion is inside the coordination sphere and 1 chloride ion is outside to the sphere. So from this chemical adduct, actually he has established the structure of the complex compound is like that, and it indicates that 4 ammonia molecule and 2 chloride ions, they are present in the coordination sphere, indicates total 6 coordination number Cn, and Cl exists as a Cl minus. So this actually gives oxidation primary valency, that is here C primary valency is equal to, here exist as CONH3 whole 4 Cl2 plus Cl minus. So here 1 chloride ion is ionizable. So here overall complex bears 1 positive charge. So 1:1 salt, a type of salt. Here 1:2, a type of salt, right? So overall oxidation number of the cobalt is still maintains 3 because 2 chloride ions are present in the coordination sphere and 1 positive charge. So this is the second inferences from this compound. And third one, is COCl3 into 3NH3. It means CO NH3 का whole thrice and Cl3, right? So this chemical adduct is expressed as CONH3 का whole thrice Cl3. Here again coordination number is 6, right? 3 from ammonia and 3 from chloride ions. So this is 6. Again the geometry is octahedral. But after adding silver nitrate solution to this compound, right, did not get any precipitation of the chloride ion, right? No Cl minus and was precipitated from this actually solutions. So this is the actually compounds. So this is neutral compounds. There is no either positive, negative or 0. So it is neutral compounds. It is neutral compound. But the cobalt still maintains +3 oxidation state, right? So this has actually blue green color. So in this way he has got various octahedral geometry through the variation of coordination sphere, right? So and in his experiment, so what actually he has elaborated that this compound bears octahedral geometry and the number of chloride ion and ammonia molecule that directly bonds to cobalt actually gives us idea about the coordination number, right? So this is the way by which coordination chemistry came into existence. And another aspect is that depression in freezing point was observed. The chemical adducts or chemical formula that furnishes total number of ions that was very high. So that was actually giving the high depression in freezing points, and the total number of ions that was actually furnished in a less amount that gives comparatively depression in freezing point higher, right? So this is the way by which coordination chemistry came into existence. Okay, so but limitations of Werner's experiment. Werner's experiment. Whatever Werner's has performed his experiment, he was not able to explain the color of the complex, right? So complex compound, why it is colored? So color of the complex compound. So he was not able to explain why color comes for a particular compositions, right? And another property that he was not able to explain, that is optical and magnetic properties. Optical and magnetic properties, right? And third point is structure, geometry, like isomerism. So these are the points that Berners are not able to explain in his experiment, that is color of the complex compound, optical and magnetic properties, and structure geometry like isomerism. So there actually he has not able to explain these points. So further the question has arises, and scientists have tried to um, explain these points and expanded the chemistry of complex chemistry. Okay, so this is the way by which uh, the origin of coordination chemistry was came into existence. So okay, thank you.